can easily build knowledge graphs from raw text using large language models. But there are a few challenges to build quality knowledge graphs. For example, here we have the knowledge graphs built using different frameworks. In these first two scenarios, as you can see, some of the entities, those are not connected to any other entities via the relationships, right? So these are called these dangling entities. That's a major issue. And the second one is the entity deduplication. For example, we might have Apple and Apple Inc., even though both referring to the same company, as a separate entities. Okay. And the third one is we need to do some pre-processing of the text so that we extract entities only from the relevant text. Okay. Now this library, it's called itext2kg, aims to address those issues to build quality knowledge graphs. Okay. So compared to these two graphs, here you can see all entities are connected to other entities and no deduplication. Of course, we can't see that from here. So it has these four functionalities as you see in this image. So we start with this document distiller. So rather than using the raw text as it is, we use this distiller to first extract the relevant or the important information from the raw text. Okay. We then use that in step 2 and 3 to extract the entities and relationships. And this is where the two things will happen. The LLM, we do what is called this incremental or repeated prompting, through which we identify if any of the entities are not connected. And for those entities, we try to establish some relationship with other entities. And also we use embedding models to identify the duplicated entities to resolve these our entities resolution. Okay. And in the final step, we just visualize the graphs. Okay. And once we inject the data into graph database, we can use graph query languages like Cypher to extract insights from it. All right. It's super easy to use. Install using pip. Now let's look at an example. All right. So we are using LangChain just to load the PDF documents. And then the pydantic model, this is not to define the entities and relationship. We will be using this pydantic in the distillation step to extract the relevant information from the raw text. Okay. So there is a difference. In general, we use these pydantic models to define what entities and relationships we want. Okay. But here we are using it for a different purpose, for knowledge distillation. All right. And from the actual library, we have the distiller and then the knowledge graph builder. Okay. And finally, we just ingest into Neo4j. All right. So here we have a resume, a standard resume. All right. Nothing fancy. So we load the resume and we split it into pages. Okay. This resume has two pages. It's a very simple resume. Here we have the content of page 1 and then the content of page 2. Now we define a schema for the knowledge distiller. Okay. So we are defining this CV data model, which has name, phone number, email, so on and so forth, and some of which are models itself. For example, work experience, which has title, company, location, so on and so forth, and education has degree, institution, location, etc. Okay. All right. So we need a embedding model for distillation purpose, for extracting entities and relationship, and finally we need an embedding model for the deduplication. Okay. So we will need two models. All right. So first we are using GPT-4o Mini for the distillation purpose, and the prompts are already within the library, but here we can provide some additional information or the directives, right? For example, here we are saying, hey, act like an experienced information extractor. You have a chunk of CV. Okay, depending on if it's a scientific article, etc., you can mention that. All right. And more importantly, if that chunk of text does not have any relevant information, keep its place empty. Okay, that's important. All right. Then just run the distiller, and here is the output from the distiller in the schema we defined here. All right. So here we have the name, phone number, so on and so forth. And then for work experience, which is another pydantic model itself, which has the title, the company, so on and so forth. And then we have the education. So as you can see here, the languages and the volunteer work are empty as per the instruction defined here. All right. And then it's super simple. So we are using the LLM again to extract the entities and the relationships by simply providing these semantic blocks rather than the raw text itself. So here we are filtering out unnecessary content. All right. So from each document, in this case, we have two documents. It extract both the entities and relationships, and this is how they look like. So first, it extracted this Emily Davis, the label as the person, and notice that we haven't specified what type of entities and relationships we want. Okay. So this knowledge, the label knowledge, it's coming from the LLM. So this is of type, contact information, email, so on and so forth, right? And for every node, we have the embedding as well. The reason why we created embedding, so that we can do similarity search to identify the duplicated entities or to do entity resolution. All right. And then similarly, here we have the relationships. So the to and fro are the start and end nodes. Emily, and she is a senior graphic designer. The relationship is simply easy. And here we have the relationship embedding. All right. Once we have that, it's super simple. Here I have my local Neo4j database, and simply inject the data into the graph database. And let me see if I still have, yeah, okay. So this is what we have extracted. It's a very simple resume. It has 19 entities and 18 relationships. As you can see from here, everything is centered around Emily, as it should be. So Emily, let's do this. So here we have the education degree, and then the company she worked at, which are in this blue. She worked at only one company. And then the skills, so most of these light blue ones, these are the skills, and the certifications are in this green color. Okay, that's all for this video. Thank you very much.